Okay. Question. The velocity of the body is given by c is equal to alpha t plus beta t plus gamma. Here, alpha, beta and gamma are constants and c is said as the velocity. Velocity in SI unit, which means and t is the time. So we need to calculate which is having the unit as meter per second, or which is velocity. Which of the unit is velocity? If we consider the equation, c is equal to alpha t plus beta t plus gamma. By principle of homogeneity, all these three of the elements will be having the same SI unit. So if we take it, which means c, we can take c is equal to alpha t, where the dimensions of alpha will be, as c is given as velocity, we take it in meter per second, as the dimensions will be L to the power of 1 and T to the power of minus 1 whole divided by time. So the dimension formula of alpha will be L power 1 and T to the power of minus 2. In the same way, if we take for beta t, c is equal to beta t, the dimension of beta will be c divided by t, which is, the dimensions of c is L power 1 and T to the power of minus 1 whole divided by t, where the dimensions of beta will be L power 1 and T to the power of minus 2. While if we take for gamma, c is equal to c is equal to gamma, where the dimensions of c is equal to the dimensions of gamma, which means gamma will be having the dimensions of L power 1 and T to the power of minus 1. So by this we can say that gamma is represented in meter per second, and gamma is also a velocity. Okay. What is the number of significant figures in 0.0310 into 10 to the power of minus 3? Okay. Let's take 0.0310 into 10 to the power of minus 3. Here we know that the rule, like the preceding zeros are not significant, so the number of significant figures is 3, as 1, 2 and 3. There are only 3 significant figures, and we are not going to consider 10 to the power of 3 as a significant figure. So there are only 3 significant figures in this number. Go on with the second number, 11.118 into 10 to the power of minus 6. So if we count the number of significant figures here, 1, 2, 3, 4, 5. There are 5 significant figures. There are 5 significant figures in this number, and we are not going to consider 10 to the power of 6 as a significant figure. So the option C is the correct answer. If we go on, which of the following numerical values has all the zeros are significant? If we take in the first number, we can see that it's 0.2020, where where only 2 zeros are significant, not all the zeros, because the zero which is preceding the point is not significant. If we go on with the second option, there is 20.0, where the zero which is inside between the two numbers is significant. If we take the number C, we are having 2020, which is, here only one number is significant. Not both of the zeros are not significant. So the correct option will be option A, where 0.2020 is significant. Okay. The question is given as subtract 0.2 joules from 7.26 joules and express the result with the correct number of significant figures. So if we consider, let's take 7.26 joules minus 0.2 joules. If we subtract the value, we will get the value as 7.06. But we need to round it off to one significant figure, because we need to round it off to the least significant figures between the two values, where This value is having only one significant figure. So the answer will be 7. So C is the correct answer. When we round it off the value to one significant figure, the answer will be 7. These questions are referred from NCERT publications and ARAN publications. Thank you.